Those memory addresses that we've been using are about to become really useful. It turns out that you can modify the contents of some objects, and without memory addresses, it would be really hard to explain what is happening. We'll start by showing that list objects can be modified. On line 1 is an assignment statement. We evaluate the expression on the right-hand side, and that creates a list object, as well as the 6 integers 0, 2, 4, 6, 8, and 10. Once we have created that list structure, we're going to assign to variable lst the memory address of the list object. So list, lst, contains memory address ID 1, which refers to the list object. At index 0 is memory address ID 2, and that refers to the 0 object. At index 1, we refer to the 2. At index 2, we refer to the 4, and so on. On line 2 is another assignment statement. On the left-hand side, we don't just have a variable. We have something a little more complex. We have list at index 2. We're actually going to be modifying that memory location right there. List at index 2, after we execute that assignment statement, is no longer going to refer to the integer 4. Instead, it's going to refer to integer 5. We are going to be modifying an object in the heap. When I click forward, we see that we have a new object at memory address ID 8, and that list at index 2 refers to that new object. Let's go edit the code and do something else. I'm going to replace this code with some other code. Let's visualize the execution. Line 1, we know what to expect. List 1 refers to a list. That list at index 0 refers to 0. List at index 1 refers to 2. List at index 2 refers to 4, and so on. On line 2, I'm doing something rather curious. I am taking the memory address that's in variable list 1, and I am placing it in variable list 2. The only thing that's going to change is the contents of module main. There we go. Now, both list 1 and list 2 refer to the list object. This is called aliasing, when two variables both contain the same memory address. Aliasing happens. So far, so good. What we're going to do now is we're going to assign to the last item in list 1, or the object that list 1 refers to, the value 17. So the item at index 5 is going to change in the list. We're going to lose the reference to 10, and instead we're going to have the item in index 5 refer to the integer 17. And there we have it. The interesting thing now is that list 2 got to watch that change happen. List 2 contains the memory address of the list object. We changed that object by using list 1, but list 2 changed as well. So when we print list 1 at index -1, print the last item, we get a 17. And we're going to see exactly the same result when we print list 2 at index -1. We will do one more example of aliasing. Here we have a function double even indices that takes a list of ints as a parameter and doesn't return anything, or rather, returns none. The docstring says double every other int in list starting at index 0, so the int values at indices 0, 2, 4, 6, 8, and so on are going to be doubled. We will start I off at 0. In other words, I is going to be the index of the next item to double, as long as there's any remaining. We're going to keep going as long as I is less than the length of the list. In other words, we will stop when I is equal to or greater than the length of the list. Within the loop, we are going to look at the item at index I and double it, and store the reference to that new value in the list at index I. Then we're going to add 2 to I because we want to skip to the next even index. Our main program is going to create a list, assign to variable list1 that list, print that list, double the integers at even indices in that list, and then print the list again. We define our function, we create our list structure, we print that list, and now notice that variable list1 contains memory address ID2, and that ID2 is the memory address of our list object. We are going to create an alias for this, but we won't use an assignment statement. Instead, we're going to do a function call. We will evaluate the arguments. We get memory address ID2, which we're going to put in variable list in the frame that is going to be created for function double even indices. Now, in function double even indices, variable list refers to that list object. Variable list1 also refers to that list object. This means that any change we make to that list object is going to be seen by both variables. We start I off at index 0. Notice that I refers to 0. The length of the list is 1, 2, 3, 4, 5, 6, 7. So 0 is less than 7. I'm going to look at the value at index 0 and multiply it by 2. The value at index 0 is 11. Multiplying that by 2, I get 22. And we are going to take that 22 and have list at index 0 refer to it. Now we're going to add 2 to I, and so I now refers to 2. 2 is less than 7, so I'm going to do the same thing, but this time with list at index 2. List at index 2 is the 13. We're going to take that 13, double it, giving us 26. And then we're going to store in list at index 2 the memory address of that new integer that we are about to get. Adding 2 to I, we end up with 4, of course. I now refers to 4. 4 is less than 7, so we're going to do this again, this time changing the item at index 4. Replace that 15 with a 30. Add 2 to I. 6 is less than 7. The list at index 6 is 17. Doubling that, we get 34. So list at index 6 is now going to refer to 34. Adding 2 to I is now 8. That makes our loop condition here false. As soon as we have false in a loop condition, the loop terminates. So we are going to exit this loop. There are no statements at the end of double even indices, and so we're about to return none. Remember, if there is no return statement in a function, then a function will return value none of type none type. Where were we? Well, we were in the main module down here. We just called double even indices. That's about to be done. So we're going to move on to line 15. List1 now refers to the list object that has 22 at index 0, then 12, then 26, 14, 30, 16, and 34. So even though we never mentioned list1 inside this function body, list1 now refers to an object that has been modified, so our output contains the new values. Because of aliasing, you need to remember which types are mutable and which types are not. So far, list is the only type that is mutable. All the others are immutable. Also, you need to be quite careful when writing docstrings for mutable types. You need to be clear about whether the parameter is being modified by the code inside the function.